Hi everybody. What we have here is a basic small steam turbine. The steam turbine's job is to take qualities of the steam, energy in it, and convert it to mechanical energy. What it does is it does it by a number of ways. And this turbine, is called an impulse turbine because what it does is it takes the steam and makes the steam go really, really fast and then lets the steam hit the blades. The blades are on the rotor, and this is the rotor right here. So this is my first stage blades, and what I do is my steam comes in here, and I govern it. I control the amount of steam in here so the turbine doesn't go too fast, and this is my governor. So the governor is directly coupled to the rotor, and the speed of the rotor will tell this governor if it needs to go faster or go slower. And through a connection here, we'll adjust my main steam into my rotor. So the steam comes in and it goes through what's called a nozzle block. It's hard to see in this one here, but what the nozzle block does is it converts that forms of energy in the steam in the form of pressure and temperature and a thing that we call enthalpy, and it converts all that energy into mechanical energy by speeding it up in the nozzle block and letting that really fast steam hit my first stage of blades. When it does it, the rotor turns and I've converted heat energy into mechanical energy. I connect something on the end of the turbine and I drive it. The steam, when it leaves the first stage of blades, goes through what's called a reversing blade assembly and turns the steam back around so that it can hit the second stage of blades, that's right over here. So this is a two-stage impulse turbine, and get more energy extracted out of the steam. Then once the steam is done there, it leaves out the back end of the turbine through the exhaust, and this job is done. We have a number of things on the turbine that are important. We have seals here to keep the steam inside the casing. So I have carbon ring seals here, and I have carbon ring seals here so that the steam isn't leaking out. If they're not doing their job as great as they should be, I have what's called deflector rings, so that if any steam does get through here, it's going to hit this and change its direction 90 degrees so it doesn't carry on down the shaft, because what I have down further on the shaft is my bearings, which allow the rotor to turn and support it so it doesn't fall to the ground. So if the steam were to get through here, it would get into my bearings. My bearings have lots of oil. Steam or water and oil don't mix so well, and it would cause problems with my bearings. The only other thing I can think of on here is if my rotor, the rotating element of my turbine, gets going too fast, there's a special device built in here called an overspeed trip. If this governor were to fail, the overspeed trip would be triggered here, and through a series of linkages would shut the steam off in a valve that we don't have available to us. Thank you.